Greetings, Year 9 students, and welcome to another exciting class on quadratics. Today we're going to be looking at factorising the harder type of questions called non-monic quadratic trinomials. So let's just revise. What is a trinomial? A trinomial is made up of 1, 2, 3 terms. Trinomial is made up of 3 terms. What is a quadratic? Well, we know a quadratic has an x squared term. It can have an x term and a number term on the end. They're not compulsory, but they are compulsory if it is a quadratic trinomial. Non-monic means the number in front of the x squared is not 1. It can be anything except for 1 or 0. If it was a -1, it's non-monic. If it was a 4, it's non-monic. As long as a is not 1, because that makes it monic, and as long as it's not 0, because if it's 0, there's no x squared, and then it's no longer quadratic, everything is in order. So these are the trickier types of questions. Let's get into it. There's just an example of a non-monic quadratic trinomial. There's a 3 in front of the x squared. Makes it harder. I can't take out a common factor of 3. If I could take out a common factor of 3, I could turn the bracketed part into a monic quadratic trinomial. Right, now there's several methods that we could use. The first method I'm going to show you is the one that the textbook uses, and it's called grouping in pairs. So let's look at what we've got to do this. First, you're going to have to take out a common factor if it exists. That's the most important step. Secondly, you're going to have to look for a factor that times us to give the letters A and C. In other words, the first and last numbers, because letter A and C actually are in the position of numbers here. We've got to find those two factors that add to give B, and we go through the grouping in pairs process. Let's do an example so it can hopefully make some sense. Here is our first question. It says we've got to factorise -2x squared, take 10x plus 12. Well, the first thing we're going to do is take out a common factor, because -2, or 2 goes into 2, 2 goes into 10, 2 goes into 12. Because there's a minus sign there, we'll take out -2 as a common factor. Leaves me with x squared. 2 goes into 10 5 times, but I took the minus out the front, so it's plus 5x. 2 goes into 12 6 times, but I took the minus out the front. And I need a second minus because a minus times a minus gives a plus. -2 times -6 gives plus 12. Now that I've done that, inside the bracket, it's monic. So this is actually not a non-monic question. It's revision to show you that even though some questions look like they're not monic, they are if you can take out a common factor. So we now have to look at numbers that multiply to give -6 and add to give 5. So what numbers multiply to give -6 and add to give plus 5? Well, let's try 1 and -6. They definitely multiply to give -6, but when you add them, they give -5. They don't give 5, so they're not correct. Let's try it the other way around. -1 and +6. Yes, they times to give -6. Yes, they add to give 5. They're the numbers I want. So -1 and 6 go in my brackets. And the -2 that was out the front just stays there. And it's similar to the harder examples we did in the previous exercise. Now let's look at our next quadratic. We can't take out a common factor of 3 because 3 doesn't go into 5, 3 doesn't go into 2. So unlike part A, this question is a bit more challenging. So when you get a question like this, the first thing you do if you can't take out a common factor is to look at the number in front of the a squared. It's a 3. And to look at the number on the end. It's a 2. We have to look at those two numbers and we have to times them together. Now 3 times 2 gives 6. So what we're actually chasing are numbers at times to give 6 and add to give 5. So I want numbers at times together to give 6 and they add together to give 5. Hopefully you can see that already. It's 2 and 3. Don't try 1 and 6. They times to give 6, but they don't add to give 5. 2 and 3 times is to give 6 and adds to give 5. So they're the numbers we want, 2 and 3. So what we do is we can write this down, and instead of writing 5a, we think of 5a being made up as 2a plus 3a, because we had the numbers 2 and 3 and they add to give 5. Now, I could write here 3a squared plus 2a plus 3a plus 2, or I could write 3a squared plus 3a plus 2. It doesn't really matter. I chose to put the 3a first because I saw a 3 in the first term. If you did it the other way, you'd still end up getting the same answer. You'd get there a different way. Now that I've done this, you notice I have 1, 2, 3, 4 terms. That makes this a grouping in pairs question. So when I look at it, focus on just the first 2 terms. That's a pair of terms. Focus on the last 2 terms. That's a pair of terms. So looking at the first 2 terms, the bit in red, 3 is common and a is common. So let's take out 3a as a common factor. What are you left with? Well, I still have, because of that squared, another a term. And because I've taken out the 3 and the a, there's still 1 because 3 goes into itself once. So we have a plus 1. Now let's focus on the green parts. 2 is common. So I'll put plus 2, not just 2. You have to have that plus sign. What's left over? 2 goes into itself once, so you get a plus 2 goes into itself once, a plus 1. Now if we look at this, there are effectively 2 terms separated by that plus. We're not worried about the pluses inside the brackets because they're combined. What we do is we notice that each term has a common bracket. The bracket is a plus 1, so we write down the common bracket, and what gets left over? 3a plus 2. And that's our final answer. We've factorized the question. Let's try question 2. Part C. We're looking at the 2 in front of the a squared and saying, oh, can I take out 2 as a common factor? If I can, it will make the question easier. Well, 2 goes into itself, yes, but 2 doesn't go into 11 nicely. Does go into 6, but because it doesn't go into 11 nicely, I don't want to take out 2 as a common factor. I'm using our slightly different technique. I'm focusing on the 2 outside numbers, or the first and last number, 2 and minus 6. They times to give minus 12. So I want numbers at times to give minus 12 and add to give minus 11. So we've got numbers at the outside numbers times together to give minus 12. So I want numbers at times to give minus 12 and add to give minus 11. So what are numbers at times to give minus 12? I've got 1 and 12. And if I play around with them, they add to give 12 and minus 1 add to give 11, not minus 11, so that doesn't work. Got a cross. Let's try it the other way around. Minus 12 and 1. They times to give minus 12 and they add to give minus 11. That's what I want. There was also other combinations. There was 2 and 6. There was 3 and 4. But I ended up not needing them. Once I've got the numbers, stop. So I know the numbers I'm interested in are negative 12 and 1. So let's write down, instead of writing minus 11a, I'm going to write minus 12a plus 1a, because they add to give minus 11a. Now I could have put plus 1a first and minus 12a second. That's okay. You'd still get the same answer. You get there a different way. Now remember, I've got 1, 2, 3, 4 terms, and you can see I've already color-coded it here. I'm going to look at the first 2 terms and the last two terms because I'm grouping in pairs. When I look at the first two terms, 2 goes into 2, 2 goes into 12. They also have an a, so I take out 2a as a common factor. Still have 1a I didn't use. 2 goes into 12 6 times, so I'll have an a take 6. When I look at the green numbers here, the second pair, I already have a take 6, so I'm going to take out a common factor of plus 1. 1 goes into itself once, 1 goes into its 6 times, so I'm left with a take 6. Now I have my groupings, I have the common bracket that I'll write down, and the leftovers are 2a plus 1. I'll go in my next bracket, finished. Part D, let's look at the outside numbers. 4 times 12, 48. So we're looking at the outside numbers. 4 times 12, 48. So I want numbers times to give 48 and add to give negative 19. Times to give 48, add to give negative 19. Well, let's start thinking about what numbers times to give 48. I'm going to guess, I know it can't be 1 and 48, or 2 and 24 don't look good. I could experiment with them, but I'm going to start by 6 eighths of 48. Now, I know I've got to get minus 19, and I know they've got a times to give plus 48, so I'm going to make them both minus. Negative 6 times negative 8. 6 eighths, 48. Negative times a negative gives a positive. That's good. Minus 6 minus 8 gives minus 14. Well, that's no good to me. So that's not what I want. Let's try a different pair of numbers. I know 3 goes into 48. Now remember, these were my numbers I had to consider between 1 and 48, 2 and 24, 3 and 16, 4 and 12, 6 and 8. Any one of those pairings it could have been. I decided to try 6 and 8 first. That didn't work. I then tried 3 and 16 because I know 3 and 16 add to give 19, so I could probably do some work with that. Make them both negative. Negative 16 times negative 3 gives positive 48. Negative 16 and negative 3, when I add them together, give negative 19. So that is actually what I want. So there are my two numbers. So I'm going to split minus 19x up as minus 16x minus 3x. And there it is. The minus 19 comes from minus 16, take away 3. I've now got my grouping in pairs. So you don't have to write in different colours. You just have to think of the first two terms, think of the last two terms. What's common in the first two terms? 4 goes into 4 and 16. There's also an x, so let's take out 4x. I'm left with an x, and 4 goes into 16 4 times. Looking at the last two terms, 3 goes into 3, 3 goes into 12. So I'm going to take out minus 3 as a common factor. And if I take out minus 3 as a common factor, I'm left with an x from the first part. But if I take out minus 3, 3 goes into 12 4 times, but I'm taking out a minus. So I'm going to need the second minus to get it back to a plus, because negative 3 times negative 4 gives positive 12. Looking at this question now, I have two terms with a common bracket. Let's write down the common bracket. And the leftover parts are 4x, take 3. And we've factorised our harder non-monic quadratic trinomial. Now let's talk about the alternate method. I don't care which method you use. What I need is you to understand what you're doing. So let's actually have a look at this question. We've got the two outside numbers. 3 times 2. 3 times 2 is 6. So I need numbers at times to give 6 and add to give 5. That's exactly the same way that I did this same question when I was using the grouping in pairs splitting up method. But here's the difference. So now I'm doing this question, I'm going to write this. I'm going to write that equals 3a all over 3. Now that'll seem really strange. Because this question starts with 3a squared and the number in front of the a squared is 3, I just put a 3 with an A, a 3 with an A, and it's all over another 3. It has to be that number there that goes in the 3 different positions. Now, I come over here, and the numbers that I was interested in were 2 and 3. So I put in one bracket plus 2, and the other bracket plus 3. We're almost finished. Now that I've done that, I look at the question and I go, if I have a 3 on the bottom, does 3 go into 3 and 3 go into 2? Well, it doesn't go into 2, so I can't do anything with this bracket. But if I look at the second bracket, this 3 on the bottom can divide into each part of this bracket. 3 can go into that 3 once. 3 can go into that 3 there once. So what I'm going to do is I'm going to cancel that 3. And I don't normally write that, I just think it. And that will leave me with 3a plus 2. Because the 3 on the bottom cancelled with the 3's in the second bracket, I end up with 1a plus 1. And that's now finished. Let's try the second one that we did using our other method. Now we start the same way. We're going to look for numbers that times to give 2 and minus 6. 2 times minus 6 is minus 12. So I want numbers at times to give minus 12 and add to give minus 11. So what numbers times to give minus 12 and add to give minus 11? Well, they're the same numbers that we came up with the grouping in pairs before. Negative 12 times 1 gives negative 12. Negative 12, when you add it to 1, gives negative 11. So I might even put a little plus sign there. It's negative 12 and positive 1. So I can go now to writing this. Double bracket over. Now this question has a's in it, and because in front of the a squared I have the number 2, I'm going to go 2a in each bracket all over 2. What else do I put in the brackets? Well, because I have a minus 12 and a plus 1 as my two numbers, minus 12 plus 1 go in the brackets. Now, looking at this 2, it's going to cancel with one of the two brackets. I can't cancel it with the second bracket because 2 does cancel with the 2, but 2 won't go into 1. Go to the first bracket. 2 goes into 2 nicely. 2 goes into 12 nicely. So let's cancel the 2 into everything in the first bracket. And if I do that, the first bracket now becomes a take 6, because 2 went into itself once. 2 goes into 12 6 times. Left with the a, so we get a take 6. And the second bracket does not change. Finished. Let's try the last example that we did using the previous technique. Let's get rid of that. And see how we go. Again, we're looking at numbers that times together. 4 times 12 is 48. So I want numbers that times to give 48, and they have to add to give negative 19. Well, we've done this before, and with a bit of trial and error we found that it was minus 16 and minus 3. Remember, we went through 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. They're all the numbers that times together to give 48, and when you look at them, the most obvious choice is probably going to be the 3 and the 16 when you first look at it, because 3 and 16 add to give 19, and I can then just play with my minus signs to get things right. And so when we played with it, we found that minus 16 and minus 3 times to give plus 48, and minus 16 and minus 3 add to give minus 19. So the two numbers I'm interested in are minus 16 and minus 3. So I come back to the question, and I can rewrite this now as 4x with a bracket, 4x, close bracket, over 4. Why did I use 4's? Because the number in front of x squared is a 4. Now the two numbers I came out with were negative 16 and negative 3. So negative 16, negative 3. When I look at it, 4 divides into everything in the first bracket. So let's go through this process. If I divide 4 into 4, I get 1. So I get 1x minus 4 into 16 goes 4. There's my first bracket. The second bracket won't change because the 4 does not divide into the 3. You can only divide it into one bracket. There's your answer. So it's time for you to try doing questions. Enjoy your wonderful experience. Bye for now.